every possible use and misuse of the tool, from the smallest hand to the biggest hand. So what we end up with is a very generic, compromised human-machine interface that relies primarily on friction between the hand and the tool for control, which has a 90-degree multiplier, and that multiplier is called the coefficient of friction. And that is probably one of the most least efficient ways of trying to stop unwanted motion, is to push down against the tool 90 degrees. You'd rather be parallel opposing forces, and you get that by optimizing the human-machine interface with a composite thermoplastic material that is remoldable. And that's important because as the worker uses the tool, they learn things about their hand touches the tool that was their best guess before. Think about it. They guess this is going to be their design. But it's not until that tool is actually put into use that they realize they start to feel something. And when they feel something, that's an indication that the grip needs attention. Because what you want is transparency. You don't want the worker to notice anything on the human-machine interface. You want a completely transparent between the hand and the tool. So like I say, manufacturers are basically developing a compromised human-machine interface so that they can sell more tools. Obviously, that's their goal for the shareholders. And so we end up with really a compromised generic service. What I can do is bring a team in, and now I can watch their tool being used at a workstation, film it, study it in slow motion, and then design services that rise up off the tool that keeps the opposing forces parallel to the direction of the unwanted motion. And that's the advantage that PersonaGrip has. And secondly, and probably most importantly, is its remoldability, which again allows the worker to fine-tune the grip until it's perfect. And when we talk about being perfect, and that is mentally transparent.